again and welcome back to our functions lessons, and in this lesson of the hyperbola we're going to learn how to draw it. Now hold on to your seat, it's not that difficult, it's actually quite easy, and you'll laugh at the end of this lesson to see how easy it actually is. So first of all, with like all of our functions, we want to go and look at the plus q first. Now, before I start, I just want to remind you that the hyperbola is of the form y equals and then it's a divided by x plus q, right? Now, please remember the plus q is actually not the y-intercept, it's the asymptote. So draw in your asymptote and check which quadrants. Okay, so how? We check the value of q. So what is the value of q in this function? It's plus 1. So let's go draw in our asymptote, and I'll do that in blue. So that will be here at 1. So my asymptote will be right down here. And let me draw that in. It's so important you do this as well, because you have to know where it is. And give the asymptote its name. Remember that any horizontal linear line is equal to where it goes through the y-axis, so y equals 1. So the asymptote here is called y equals 1. And you can indicate this 1 here as well. Okay, there we go. Now, find your x-intercepts. Now, how do we do that? Just like with all the other functions, make y 0 and solve the equation for x. Now remember, this is an equation with a fraction, right? So let's find the x-intercept. Here we go, the x-intercept. And it will look like this. Make y 0. So 0 equals 2 divided by x plus 1. Now, what do? We take this plus 1 to the other side. Then it becomes a minus 1 equals 2 divided by x. Now we have an equation where there's a fraction. So what is the LCM of the denominators between 1 and x? It's a x. So my LCM is a x. So first of all, x divided by 1 is x. X times minus 1 is minus 1x equals. And then x divided by x is a 1. 1 times 2 is 2. And there we go. So now we just want the x. So then what do? We have to divide with the coefficient here. So 2 divided by minus 1, and I'm just going to write the answer. So 2 divided by minus 1 is a minus 2. So now I know what my x-intercept is. It's minus 2. So let me go and plot that in blue. There we go. But now I know that this whole hyperbola for this function will be in the positive quadrants because a is positive, right? Okay, so it will be up here and it will be down here in the two positive quadrants. Now remember, we just moved the initial asymptote, which was on the x-axis, we moved it up. So now we move that quadrant up. So it will start here close to the asymptote and then go through the x-intercept and all the way down. Remember, it can never cross my y-axis because my y is my vertical asymptote, right? So to draw this properly, what I'm going to do is I always find 2 more points, even 3 more points. Now, how do we do that? We draw a table and choose 2 appropriate x values or 3 appropriate x values and solve for their y values. And that is what I'm going to do. So I'm going to draw a table. I'm going to say this is my x and that's my y. And then I'm just going to choose my x values, maybe around 3 of them for now, okay, because I really want to draw this accurately. So let's choose a x, for example, minus 1. So if x is minus 1, then we take that minus 1, we substitute it into the original function. So 2 divided by minus 1 is a minus 2. Minus 2 plus 1 is a minus 1. So y will be minus 1. Okay, so where is this point where x is minus 1 and y is minus 1? X is minus 1, y is minus 1, it will be over here. So let me plot that point. Okay, there we go. Let's choose another one in the other quadrant. Okay, so let's choose, for example, when x is 2. So if x is let's make it a 1 and then we go for 3. So let's make x 1. So if x is a 1, okay, so that will be 2 divided by 1 is 2. 2 plus 1 is 3. So then y will be 3. So if x is 1, y will be 3, which is over there. So let's plot that point as well. There we go. And then the next one, let's choose x, for example, to be 2. So if x is a 2, then we know that 2 divided by 2 is a 1. 1 plus 1 is 2. So then y will be 2. So where will we find x, which is 2, and y is 2? That will be over here. And there we go. Okay, so now at least I know what the hyperbola needs to look like. It will start close to the asymptote and move closer to its vertical asymptote. So let me draw that in black. So it will go from there through that x-intercept and all the way down, and it will never cross the y-axis. It will never cross that asymptote as well. So now we have to draw the other part in the top quadrant there, and we have our 2 points. And remember, it will never cross this vertical asymptote, and it will never cross the horizontal asymptote. So it moves very close to it, and it moves very close to this one, and it continues but never crosses. So it will go like this. So go down through that point, and it continues all the way, and there we go, and there we go. So that is what it looks like. And now I can just quickly mention those 2 points, which is 1 and 3, and this point here will be 2 and 2. And we can do the same here at the bottom. We know that is -2 and 0, and this will be -1 and -1. And then we are done. So the table here helps us to draw this very accurately. You just have to remember the 2 asymptotes. Remember my vertical asymptote, and I'll quickly draw that in green because I want to show you, if they ever ask you what is the equation for the vertical asymptote, then you know that this is the same as a vertical linear line. So where does this go through my x-axis? At 0. So basically this one will be called x equals 0. And that will be this vertical asymptote. For you in grade 10, the vertical asymptote never changes, but the horizontal one moves up or down, which changes the quadrant, either making the quadrant go up or the quadrants go down. In this case, the quadrant moved up because the asymptote moved 1 up, right? Because +1. Now let's go and try some more examples. Now here is an example that you can try. Here are the steps. Give it a go. Once you are ready, resume the video to see if you are correct. Now please make sure that you know that this is a hyperbola. And how do I know? Because it is of the form y equals a over x plus q. So the first thing is we always look at q, which is my asymptote, and we draw in our asymptote at -2. So there's -2, and I will quickly plot that point, and then I will draw my asymptote all the way through that -2. Remember, it's not a y-intercept, it's just an asymptote, which means it is like a borderline which the hyperbola cannot cross. Now let's quickly look at the a. Now it's a -a, okay? Don't worry if the minus is there at the front. That minus belongs to that 3, so it's a -3. So it will be in quadrant 2 and in quadrant 4. Now look, my quadrant moved down, so it will go through the x-axis and towards the asymptote, and this one from the asymptote again to my vertical asymptote. So let me quickly draw in this vertical one just to show you, because we know in grade 10 that it doesn't change, it stays on my y-axis. So there we go, and we call this one x equals 0, and we call this horizontal one, we know that it's y equals -2. Okay, great. So this is my 4th quadrant now, and that one is my 2nd quadrant. Now what we need is, we need the x-intercept, because we know we are going to have one. So how do we find the x-intercept? That's not too difficult. The x-intercept is when my y is 0. So 0 equals -3 over x minus 2. And then we take that -2 to this side. It becomes a +2 equals -3 over x. And now we have an equation with a fraction. So we put this over 1, make everything into a fraction. And then we have the LCM of the denominators, which is 1 and an x. So the LCM is a x. Okay. And just to show you, when we have a fraction when the denominator is a variable, x cannot be 0, right? Okay, so please remember this. X cannot be a 0, and it makes sense because if x is a 0, this is undefined, right? And look, x is equal to 0, it's here, so it can never cross here. Okay, it can never cross this, then x had to be a 0, so it cannot cross this vertical asymptote. That's why x cannot be 0. Now, let's just continue here. So LCM is x divided by 1 is x times 2. That gives me 2x equals, and then x divided by x is 1. 1 times minus 3 is a minus 3. And then we know that x will be equal to minus 3 divided by 2, which is the same as minus 1.5. So where can I find minus 1.5 on my x-axis? Is right between minus 1 and minus 2. So right there, let me plot that point. There we go. Okay, so now I know it will move towards this asymptote, and it will move towards the vertical asymptote. But I want to draw correctly, so I'm going to choose x values here so that I can find the y values, and I'm going to choose x values here so I can find the y values. Okay, so let's quickly see what I do. I'm going to quickly draw a table. So I will say x and I will say y, and then I quickly choose 2 or 3, even 4 values for x, and then find their y's. Now I always choose the easy ones, and I will quickly show you how. Because if this is minus 3 over x minus 2, to do an easy calculation, if x is a minus 1, because minus 3 divided by minus 1, we can easily do that calculation in our head. So let's just do that. So x is minus 1. So whatever divided by minus 1 will stay that one with the sign change, right? So minus 3 divided by minus 1 will give us a 3. Because minus 3 divided by minus 1 is a positive 3, and 3 minus 2 is a 1. So if x is minus 1, my y will be a positive 1. And where will we find that point? Minus 1 and 1 right there. So let's plot that in. There we go. And then we choose another x value. Let's try and choose one for this quadrant. Now let's choose a positive 1. So if x is a positive 1, we just take that x, put it in x's place. Minus 3 divided by 1 is a minus 3. Minus 3 minus 2 is a minus 5. So this will be minus 5. So let's plot that. If x is 1, y will be minus 5. That will be right here. Okay, great. And the next one, let's choose a value, for example, a 3, because it makes sense. 3 divided by 3 is an easy calculation. So let's make x a 3, and then minus 3 divided by 3 is a 1, a minus 1, and a minus 1 and a minus 2 gives us a minus 3. And where will we find that value? If x is 3, y will be minus 3. So there it is. And now it's quite easy to draw it in. So let's do that. And it will go like this, and all the way down there, and never go and cross the asymptotes. How about this one? We know that it will start up at the top, go down, 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 and it will never cross this asymptote, so it slopes away from it. And there we go. So that is my sketch done. So it's quite easy if you know why you choose these values, because positive x's are here, and you choose the ones that you can easily calculate, like 1 and 3, the same as the numerator, then it's easy to calculate. For example, like this, minus 3 divided by 3 is a minus 1, minus 1 minus 2 is minus 3, so it's easy to calculate. And here I just choose the minus 1 again because easy calculation, right? So there we go, and then sketch accurately, and there it is, and it's not that hard. So don't forget, plot in your asymptote, set up your table, choose your values for your table, and make sure you plot them in the right places. Okay, brilliant. So I hope to see you in the next lesson, where we will determine the equations for the hyperbola. Bye. This is your host Richard T, and thank you for joining us. Please visit our website mathsa.co.za for free guided exam tutorials.